Okay, guys, for the second part of this problem, what we're going to do is we are going to look at now if this charge is moving at this high speed. So let's go ahead and copy down what we have from part one of our problem here, which is we have a proton. Okay, so we have a proton, and we know its mass. The mass of our proton, remember, is 1.67 times 10 to the negative 27 kilograms. Okay, and we know that the velocity that it is moving at, or the speed, sorry, I should say, so I'm going to go and take off this little vector symbol and just say the speed of our proton now is 2 times 10 to the 6th, okay, meters per second. So what we need to do is find now what shape its path will take when it's in a magnetic field. This is a very strong magnetic field right here. 2.2 Tesla is quite a large field, okay? But we're moving very, very fast. So we're going to see how this all nets out. So what we have here is this charge is moving perpendicularly to the magnetic field. So we're going to have a charge here. Let's say the easiest way maybe to draw this would be to have my field here coming out of the page. Okay, so I'm going to go ahead and draw this field here is kind of coming out of the page. And what we're going to do is we're going to have our charge, our positive charge, is going to be moving to the right. So it just has to be perpendicular. So we're going to choose a direction here to the right because it's easy for us to visualize this. So what's going to happen is if you use your right hand rule, okay, your fingers, your first four fingers pointing in the direction of the magnetic field, and then you've got your thumb of your right hand pointing in the direction that your charge is moving. You should have your palm facing downwards, okay, downwards relative to the page. So we will have this direction right here will be my force, okay. So what will happen, of course, is that the path of the proton will start to curve downwards, but when it does, then so does the direction of my force. Now my force is going to be curving as well, still pointing towards the center of the circle, and so it'll make this circular path, right? So we'll have this circular path right here that our proton will follow, okay? So now that it's doing this, I want to know what's the radius of this path right here. Okay, how big is this circle that it's going to make? This is another concept that we are going to connect to our physics 1 mechanics, right? Is we have here, we know the amount of force that is applied to a charge moving in a field. We have this force right here. We're going to go and write this, okay? I'm going to call this force of my magnetic field is going to equal to my charge times its speed and then my magnetic field. And I'm just going to go ahead and put the sine theta already. Remember that this is a cross product, but right now we just have QVB sine theta, okay? But these are perpendicular to each other all the time, no matter where I am in my circle. It's always perpendicular to my magnetic field, which is out of the page. So this part right here is just 1. So I end up with just QVB, okay? And here we're going to go ahead and list out also one more piece of information so that we don't forget that the charge of my proton, so Q of my proton, is 1.6 times 10 to the minus 31 coulombs, okay? So we want to have all of our information here that we're going to need. So we know the amount of force that is on this charge to move towards the center. Okay, this is great. We could plug everything in here. We've got our magnetic field, we've got the speed of our proton, we've got its charge, we've got everything. But how does this actually relate to the size of the circle that it's going to make in its while it's traveling in the magnetic field? Well, we have our formula from physics 1 for centripetal force. Okay, this is a centripetal force. because it's moving in a circle, right? So this force is keeping it in a circular path. So what we need here is our formula for centripetal force, which is equal to m times speed squared over r. Okay? Now, both of these forces are equal because the force that my charge experiences because of the magnetic field is the force that is keeping it moving in a circle. So these two things are equal to each other, right? So we can just bring these guys together, okay, and set them equal to each other. So we have QVB is equal to mv squared over r. So if I want to find the radius of this path now, all I need to do is solve for r. So very simply, let's go ahead and do that right now. So let's multiply both sides by r. Go ahead and get rid of this. And then let's go ahead and divide both sides by QVB. Okay, 1 over QVB. So this will cancel on this side. And we end up here with r is equal to mv squared over, oops, sorry, this should be QVB. And here I have v squared and I have v, so these two things cancel out, right? So this here is just equal to mv over QB. Okay, so all we have to do now is plug in our values, which we have right here. We can go ahead and do this. The mass of our proton, 1.67 times 10 to the minus 27. Our speed here is 2 times 10 to the 6th. Our charge here is 1.6 times 10 to the minus 19. And my magnetic field is 2.2 Tesla. Okay, so last step here, now we've plugged everything in. All we need to do is put this into our calculator. So last step is always the easiest for us. Negative 27 times 2 times 10 to the 6. Okay, 1.6 times 10 to the negative 19 times 2.2. So we should have, so what I just got here by plugging this in is 0.009. Let's go ahead and call this 0.0095. So this is actually 9.5 millimeters. Okay, this is in meters, now in millimeters. So that you guys have an idea of how big this circle is. Even though my proton is moving so fast, it's 2 million meters per second, but it's moving in this field that is incredibly strong. Okay, so it ends up making a very small circle, about 1 centimeter, right? Just about 1 centimeter will make this tiny circle at this very fast speed.